Hi guys. So there's this result that's really satisfying or relaxing to probe because the way the result will pop out at the end, like that feels kind of coincidental or satisfying. Yeah, that's the reason. And there are two reasons for making this video. First of all, just to prove this one. But I would also like to introduce you to the alternating sum of natural numbers raised to some power, right? Because there will be few videos on that topic on my channel next. So yeah. So first of all, let me introduce you to like the kind of sums I want to deal with in my channel. Okay, so I know that to perform this, wait. Okay, I know that to perform such sums, like let's say 1 to the power k plus 2 to the power k plus 3 to the power k up to n, for this kind of sums, we need Bernoulli numbers, right? We need Bernoulli numbers. And we also know results for, let's say, when k is 1, the sum is n into n plus 1 by 2. When k is 2, the sum is n plus 1 to n plus 1 by 6. Right? When k is 3, it's n square n plus 1 square by 4. Right? We know for results, and for others, we have generalized formula using Bernoulli numbers. Now, similarly, have you ever thought of such sums like minus 1 to the power k plus 2 to the power k minus 3 to the power k plus 4 to the power k minus 5 to the power k plus 6 to the power k, and such sums? Have you tried to find their formulas for, let's say, k equals to 1, k equals to 2? Can you try to find formulas for these cases, right? And can you generalize it? Yeah. And do you think that there's general result for some k power? And the answer is yes. The answer is there are general results in terms of Euler numbers. Yeah. And try to look it up what Euler numbers are, which will be my next video, where I will compare the Bernoulli numbers and Euler numbers, right? And also, we are going to deal one of such sums in this video, where k is 2. We are trying to find the answer because in many other cases, like the results for odd and even powers can differ, but for k equals to 2, it's same. So yeah, that's why I'm dealing with k equals to 2 in this one. So let's try to prove this. Now, first of all, let's try to write this sum. Okay, so this sum can be written as minus 1 square plus 2 square minus 3 square plus 4 square minus 5 square plus 6 square, and so on up to the last term. Yeah, in last term we'll have a plus sign, a minus sign, depending on, okay, last term we'll have n over here, not k. Okay, the last term will depend on whether there are even number of terms or odd number of terms, right? Now, how do you find this form? Okay, so let's deal with case by case. Now, suppose that there are even number of terms. In that case, we can basically group two terms, right? We can group minus 1 square and 2 square, minus 3 square and 4 square, minus 5 square and 6 square, minus 7 square and 8 square, so on, and minus n minus 1 square plus n square, right? Now, to find its sum, you can use the formula that a square minus b square is basically a minus b, a plus b, right? Using this will be just 2 minus 1, 2 plus 1. But we know that 2 minus 1 is just 1. So this is just 2 plus 1. You see that? So this is just 2 plus 1. Just like that, this sum over here is 4 minus 3, 4 plus 3. So this will just be 4 plus 3. The next will just be 6 plus 5. And then 8 plus 7. And then 10 plus 9. Yeah? This goes on. And again, this goes on up to n plus n minus 1. Now, do you see that this is actually just a sum of the natural numbers, right? And we know that the sum of the natural numbers is n into n plus 1 by 2. So you saw that So you actually saw that for n is equal for k, this over here, this number 2, and if n is even, in that case the answer is just n into n plus 1 by 2, which is exactly what this says. If n is even, this will just go to be 1, and that's what the result is saying. Now let's try to find it for odd numbers. Now usually it may not happen that we have same formula for odd and even, but in this case we get the same formula, and that's what gives the satisfaction. Now for odd number, the sum will be minus 1 square plus 2 square minus 3 square plus 4 square, right? Minus 5 square plus 6 square, and minus n minus 1 square. Oh wait, this time since it's odd, the last term will have negative sign. Yeah, since over here the last term was positive, but over here it's different. Now in this case we'll just leave the first term as it is and group the other terms, right? Minus 1 square, and then this is plus 2 square minus 3 square, and then plus 4 square minus 5 square, 6 square minus 7 square. Since we are leaving one of the first terms, the other terms should group, right? Because if we take one from odd, it becomes even. And this is n minus 1 square minus n square. Again, you use the same formula. Over here, it's 2 minus 3, it's 2 plus 3, right? So we will have negative sign times 2 plus 3. So over here, we have negative signs times 2 plus 3, so that's negative to negative 3, right? Over here also negative signs times 4 plus 5, so that's minus 4 minus 5. Over here it's minus 6 minus 7. Over there it's minus 8 minus 9, and so on. Over here it's minus n minus 1 minus n, right? Now if you take negative, and now if you take negative sign common, I can write 1 square as just 1. This is 1 plus 2 plus 3 plus 4 up to n. So we see that the sum is negative of n into n plus 1 by 2. And yeah, so we have got that the sum is negative of n into n plus 1 by 2, for even it's positive n into n plus 1 by 2, right? So if you want to generalize this result, we can just add this negative 1 to the power n factor, because this will go to 1 for even n, and this will go to negative 1 for odd n, right? So that helps us generalize the thing. And so this problem is actually proved. If you want to check it, let's say I want to find this sum, minus 1 square plus 2 square minus 3 square. Since now the sum should be minus 1 to the power 3, 3 into 4 by 2, right? This should be minus 1, 12 by 2, which is minus 6. So let's check. Minus 1 plus 4 minus 9, minus 3 oh wait, this is plus 3. Plus 3 minus 9, which is minus 6. So this works, right? Now let's check for another number. Minus 1 square plus 2 square minus 3 square plus 4 square. Minus 1 to the power 4. 4 into 5 by 2, which is minus 10, right? Over here it's minus 1 plus 4 minus 9 plus 16 minus 10 plus 20, which is 10. Oh wait, yeah, sorry, this is plus. This worked, right? So you can see that this formula works, and yeah, this is a really nice formula. Yeah, and also try to research on this topic if you want to. This is also interesting. These are also interesting things. So that's the takeaway for today. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.